Hello guys, welcome to this channel, Tough Math. I am Napoleon A. Gaking Jr., a math teacher. If you are a math teacher or a math coach or a math contestant or simply a math enthusiast, this channel is for you. The mathematics problems that are featured in this channel come from various national and international mathematics competition held during the past several years, and they appear here either in their original forms or in their repurposed versions. As such, they will be an excellent source of review or training materials, especially for those who intend to compete in some mathematics competitions in the future. So without further ado, let us now look at the two problems that we will consider here. Okay, problem number 1. Let T be the set containing the numbers 1, 2, 3 up to 2026, and S is a subset of T, such that if X and Y belong to S, then 5 does not divide X plus Y. At most, how many elements does S have? Okay, so first, if 1 is an element of S, then all numbers of the form 5k minus 1 are not in S. Because if they are in S, then their sum is divisible by 5. Therefore, both X and Y cannot both belong to the set S. Only one of them can belong to the set S. And the smallest of these numbers, the smallest of which is 4, and the largest is 2024. Now, when when 2024 is equal to 5k minus 1, this gives us k equals 405. This is 25 over 5, which is 405. That is 405 elements of T that is 405 elements of T do not belong to S. Next, if 2 is in S, if the number 2 belongs to S, then all numbers of the form x equals 5k minus 2 do not belong to S. Again, for the same reason that if x belongs to S, then their sum would be divisible by 5, thereby contradicting the assumption of the problem. The smallest of which is 3, and the largest of which is 2023. And this means that k is equal to 405 again. That is another 405 elements of T are not in S. Then next case, if 5 belongs to S, then all numbers x which are multiples of 5 are not in S. Now, if 5k equals 2025, this gives us k equals 405. However, since 5 is an element of S, only 404 multiples of 5 that are in T are not in S. Therefore, S has at most S has at most 812 elements. Okay, so that's the answer for the first problem. Now we go to problem number 2. How many positive divisors does the number n have, where n is equal to 83 times the quantity 84 to the 5th plus 84 to the 4th and so on, plus 1. Okay, so we start by letting x be equal to 84. Then n can be written as x minus 1 times x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus 1 quantity plus 1. Which is equal to x to the 6th plus x to the 5th plus x to the 4th plus x cubed plus x squared plus x minus x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus x plus 1. Plus 1. And this expression simplifies to x to the 6th, which is 84 to the 6th, which is 2 times 2 times 3 times 7, which is equal to 2 squared times 3 times 7 to the 6th, which is equal to 2 to the 12 times 3 to the 6th times 7 to the 6th. Therefore, n has exactly 13 times 7 times 7 equals 637 positive divisors. Okay, so the answer to the question in the problem, how many positive divisors does n have? The answer is 637. So that's it for our problem number 2, and that's it for this video. I hope you enjoyed our discussion for today, and if you are interested to see more problems, mathematical problems solved in this channel, please subscribe, and see you in the next video. Thank you and God bless.